Hello, my name is Corey McCall, and today in this presentation, we're going to discuss conducting linear regression tests. First on the agenda, we're going to go over an introduction. Then we're going to talk about our first linear regression test. Then go into our second linear regression test. Then our third linear regression test. Some takeaways. Then we're going to discuss three articles. We're going to start off with Article 1. Then we're going to go to Article Review 2. Article Review 3, then a summary, and then lastly open it up to questions. So starting off with the introduction, a linear regression is used to determine there is a significant relation in a data set. The confidence interval is used in support of the result of a linear regression test. In our first test sample, we see that there is no significant result found. We first look at our first hypothesis test. The null hypothesis states the regression coefficient beta is 0. The alternative hypothesis states the regression coefficient beta is non-zero. A simple regression was conducted to determine if we can predict an individual's debt by knowing their income. No statistically significant regression emerged. As a result of the test, we have the test failed to reject the null hypothesis, showing we cannot predict an individual's debt by knowing their income. Also, the number 0 is in the 95% confidence interval for beta. As you can see, the p-value is 0.535, which is much higher than the constant of alpha of 0.05. APS predicts knowing someone's debt will not have relation on their income. Further, the confidence interval does not contain 0, hence lending support to the prediction. In our second sample, we are seeing that the null hypothesis states the regression coefficient beta is 0. The alternative hypothesis states the regression coefficient beta is non-zero. A simple regression was conducted to determine if we can predict an individual's savings by knowing their income. A statistically significant regression emerged. We can reject the null hypothesis because we can predict the individual's savings by knowing their income. As you can see, the p-value is 0.00, which is much lower than 0.05 of the alpha, which showing there is a significant relationship. Savings equals 0.91 times the income of minus 203.47. Savings is predicted to decrease when someone's income increases. Further, the 95% confidence interval of 0.09 and comma 0.11 does not contain 0, hence lending support to the prediction. In the third linear regression sample, in our third hypothesis test, we're seeing that the null hypothesis states the regression coefficient beta is 0. The alternative hypothesis states the regression coefficient beta is non-zero. A simple regression was conducted to determine if we can predict an individual's stocks by knowing their savings. A statistically significant regression emerged. We can reject the null hypothesis. Thus, we can reject the null hypothesis because we can predict an individual's stocks by knowing their savings. Stocks equal 0.28 times the income plus 1006.73, and as you can see, the p-value is equal to 0.00, which again is significant because it's below the alpha constant of 0.05. APS is predicted stocks will decrease as savings income increases. Further, the 95% confidence interval of 0.07 and 0.25 does not contain zero, hence lending support to the prediction. Some takeaways. Takeaways from these three tests, we can see as a constant, PSPP is used to produce the test result of a linear regression test. There were two significant test results that predicted a relation between the independent and dependent variables. The values in the 95% confidence interval for beta will show support in relation to the significance or non-significance of a linear regression test. Also, the p-value is another statistical factor in determining whether the null hypothesis is supported or the rejection rule is applied. In an annotated bibliography, one of the first ones I chose was what is a p-value? The author goes on to state what a p-value is and also describes that it's used in statistical testing in terms of context, process, and purpose. The null hypothesis is also mentioned as the test hypothesis targeted assumption. We can test and discover the effect of test sizes. If there is a significant effect, the effect can be measured. I chose this one because it spoke about what a p-value is in relation to a null hypothesis. In our second annotated bibliography, Eyewitness Testimony, the Influence of the Wording of a Question, this article explained gathering data to either confirm or deny a hypothesis or assumption. I use this article to explain how the data is derived from surveys or means in which various tests are performed upon. In our third annotated bibliography, we're discussing the Handbook of Biological Statistics. It explained as determining whether the significant relation occurred by chance. It's performed by taking a sample size and two nominal variables, then determining if portions in the first variable are different than the values in the second variable. I chose this because it's important to gauge whether a data set is credible to be used upon a given relation test. Summary: the main factors that determine a significant relation are the p-value and 95% of the confidence interval. There are more factors, however, the p-value is less than if the p-value is less than alpha, which is 0.05, the null hypothesis rejected each time. PSPP is used to perform a linear regression test from survey data or another type of data set. The chi-square test can determine if the data from a significant test results are by chance. Now we're open up the floor to any questions. Thank you.